first office that we did was in Niagara, which was, of course, our biggest TBM ever, 13.4 meters diameter. And that gave us a pretty aggressive schedule. This was Strabag, a company we'd worked with on several projects before. We did Manipuri with Strabag. So it was a customer that knew TBMs, knew Robbins, knew our capabilities. And so we were able to agree on a contract, an off-the-top contract. And actually what happened here is we were able to start pouring 12 months after we signed the contract, which was a really good feat. I think we kind of surprised a lot of people. I know we surprised OPG, the owner. They afterwards, they said they didn't really believe that schedule was going to happen, but it did happen. And it was a real good experience for us and Strabag and the industry, I think. Another one we did was in the Jinping project in China, in the western part of China in the mountains. Here we didn't do quite as well because we were more remote. We did OFTA. We were looking to, from the time we started to receive start our manufacturing process, we were looking to finish up a schedule. So we were looking to do it in if we did it with OFTA, we were looking to do it in 225 days. And then if we factory assembled, we were looking to do it in 260 days. That was just our own internal comparison. In some cases, we do better than that, but this was on this particular Jinping project. But we had a lot of problems, as you can have in remote sites. There was delays in the shipments because of weather. There was some delays in our pre-assemble, and we lost some time to that. We also got caught in that big earthquake that happened near that job site. But I'll just run through how this process works. There's quite a few slides here how this Jinping machine went together. And here we are just machining a part in one of the factories that we use in China. And I must say we've had good luck with a lot of these shops, and we spent a lot of time we've been there in China manufacturing for about 15 years, and we spent a lot of time just getting the shops up to speed, understanding what our quality control really means. And we've been able to duplicate our quality control systems in China as we have here in the U.S. and as we have done in Europe. It's a process. The process we understand, and we've done it successfully. After we do all the machining, of course, we do the sub-assembly, and then we put in the gears and make sure everything checks out. We actually built a total backup system. You can see the magnitude of this backup system. It's, as you can see, quite massive. And we did this structure as close as we could to the back, to the site, to just, again, reduce overall freight costs. And when we got all the components fabricated, of course, we had to take them apart and fill them up there, put them on a boat going up the Yangtze River. And this is how they looked on being barged up the river. And again, what's interesting is after you put the total machine apart, you have to break it down in these component sizes in any event. And we had a staging area about 50 miles from the site where, again, we moved because of the shipping logistics, we decided to use the staging area and move the components in as the site required them. This is the assembly site underground. You can start to see it. There's a very nice looking Chinese truck there, as you see. But this is a hall for assembly, built just specifically to assemble this machine. You can see it's just like a big hall in a workshop. There's no difference. You need the same size of frames. You need the same specialist there. You need the same tools. So it's these workshops, or in this case, it was just like working in an assembly hall. And this is some loading of the key parts, movement of overhead assembly, and the problems of just moving these large components. machine going together in a vertical position. This whole process took about, as we go through this thing, it looks pretty quick assembly here, but there's a lot of components, a lot of putting up, and I don't have the slide here. We did have some fit problems on this particular one. I'll address that later. After we get the cutter head on the machine, we have to weld up the components of the cutter head, and the components of the cutter head have to be welded in any event. Even if we did shop assembly, we ship these cutter heads out in several pieces, and then we have to weld them up. This is we always supervise this. This is very key to us to make this cutter head correct. Nothing more key in these rock projects than getting a good cutter head. After we get it machine assembled, of course, you got to move it out of the assembly chamber, then you got to assemble your backup, and then you got to move it forward and assemble the chamber. So there's a big, long process to this assembly in any case. We'll just take a break here and go into another set of questions, poll questions, and while you're answering these poll questions, again, Brianna, maybe you could put in a question from the audience.
Yes, another question. How much space is needed for OFTA, and can TBMs be assembled on small footprints or in shafts?
Yeah, that's another question that's asked quite often. Well, you got the space you got. The site decides on in the early planning stages how much space we got. If it's a shaft project, of course, you got to get the components down the shaft, and you have to deal with the space within the shaft. And that's true whether it's OFTA or it's true whether it's without OFTA. And what we have done is actually, when it's a shaft project, put the backup on surface and then completely assemble the backup and then lower it down as we need. But what we really like is some of the sites like we did out in India where we're just open and we can have the whole length of the TBM and the backup to assemble in just one long process. And but that's rare. Most of the OFTA sites we've been to, we've got limited space, and we just deal with that space as if it was a shop assembly. It's really no different. So I think we got the polls up. We've got a lot of consultants online here and interested in the process, which I'm pleased to see because that's what has to start. If we're going to get acceptance of this method, then we got to get the planning people involved. Another couple of projects we did were out in India, pretty remote site. This worked pretty well. This is one of the biggest projects that has ever been done in the industry. This is a 43.5 kilometer tunnel in very, very hard granitic rock. Quartzite on the other end. We're putting two 10-meter machines on this project and no intermediate access shaft at all. So this was another place that we've done this OFTA. And here you can see that the site layout. You can see that you've got a nice big long site. And again, of course, we just are duplicating a workshop environment here. We have to have these huge hoists. We have to have mobile hoists, mobile cranes, and workshops, tool shops. All of this stuff we move in containers to make sure that we're prepared and ready to do the process. And in this AMR project, from the time the first big prices arrived at site, it took us 16 weeks before we started to turn the cutter head and cut the rock. And again, here we estimate that we knocked off about 4 to 5 months from the total process that we've done shop assembly. And of course, we saved the freight and the shop assembly, disassembly later. Again, a nice photo of what goes on. And we, in this case, we had about 18 specialists, Robin specialists on the site, and then we had local crew, our own local crew of about 25 Indian specialists that we pre-trained on this and trained as we went. And yeah, the site's pretty remote, but this one worked very well. Another good success we had, and this is one of the best stories I like to tell, is from Mexico City. This is an OFTA project at EPD. A lot of people don't realize that Robbins is big time in EPD. We actually we had more EPD business last year than even our hard rock business, selling. I think we're on 9 machines last year and only 7 rock machines. So EPD business is starting to be big time for Robbins. And this is a classic OFTA. Again, we shipped the pieces to site, and after they arrived on site, the first pieces, we were actually started to test the machine after about 8 weeks, and we were started to break through or push out the starting blocks and into the slurry, the cutoff wall at about I think it was around 10 weeks, and everybody was pleased with this effort. We got real good support from the contractor of this project, ICA. They're a real good company to work with, and they supplied excellent people. They put together 4 or 5 other machines down there, mostly our competitors' machines. But so it was nice to receive a real experienced crew and work with them. It just worked right off the bat, and they were boring in good time. And we've had good success. This UPD machines for about, we started boring about 1 year ago, even less than a year ago. We're in nearly 4,000 meters and through, I think, 3 stations now. And the customer's happy. When the customer happy, I can assure I'm a little happier. So it's a good success. One thing unique about this project was we actually were removing muck by pumping the system. We have a double screw arrangement here because of the high pressure and the boulders we expect. And we're actually now switching from pumping system to conveyor. That was a planned program, and because we're expecting a lot more boilers in the last 6,000, I guess it's about 4,000 meters a ton, and we're going to switch to a conveyor system with a vertical conveyor. Again, this was kind of like an open cut right down in the center of the city, Mexico City. Of course, a very busy place. As I said, we started in mid-November. There was logistics to get all the pieces in. There wasn't a lot of room at the site. But with good cooperation, we fit all that in, and we're up and running. It was a pretty good time. And what was interesting about OFTA is, of course, the number of times we've done it now and the successes we've had. First, as I said, with Niagara, we've had 2 at AMR. We're actually 2.5 must go, because one of the sides of that tunnel in AMR got flooded out just as we were about to start the bullet. So we had to come recondition all the pieces and do it once again. So I don't know if you call that 2.5 or 3, but we'll be going on the other side of that project in a couple of weeks. Mexico City, Telagunda, another place in India, Jinping, as I said. And right now we've got 2 projects under construction. One is Manabana remote. We've had to struggle there a little. We're more remote than we have been in India, and we came in with too few parts. We had a few, took it longer than we expected. But it's just about ready to bore now. And we're just starting on a big 10-meter machine in Turkey, double shield. It's off there as well. So again, the started boring. The benefits of the started boring has always accelerated. I think even with where we've had some problems, we've always been faster than if we'd shop assembled. I think we understand after these projects, 8 or so projects, we understand the risks. We're getting better and better at it, and I think we'll keep improving our game here. I'm going to show you how a little video clip here, and I'll just be off the air in a minute while it's running. I assume I'm off the air.